But
I thought everybody was here already, man. That was all for
yeah,
show.
people are joining. So we're all
Awesome.
wearing our baseball caps and the real hat with
I got to
deflection.
tell you that I'm a little bit disappointed in the three of you. All right, because there are.
We
Damn.
didn't. So, all right. Well, thank you everybody out there for joining once again. This is another Power Hour. I'm Dan Edelman. I'm with PowerHour Insulation, and I'm also joined by a few guests today. Very special guests. They always are. Everybody's special out there too. So, I'm going to go around and basically, what we do. This is all about collaboration and education. We basically have a discussion. We have fire expert James Bourget on with us as well from RDH Building Science, who has a lot of information. Honestly, probably definitely more than an hour, probably more than a week worth of fire investigation, work, and building science and other knowledge as well. So I met James actually back in probably almost a year ago at this point, but we went to the Power Hour down in Austin, Texas with Matt Reisinger and on a Power Hour down there on a webinar. And now we're talking more about fire because we did miss it on the Power Hour that was down there just because there was so much information that was getting thrown around down in Austin, Texas. So I'm going to go around and just do quick introductions. Again, I'm Dan Edelman. I've been with PowerHour Insulation for less than a year now, but been in the mineral wool category for about 15 years. So I was with Rockwool Insulation since 2011. Prior to this, I also was with Phillips Screw Company and Timber HP as well. So getting the fasteners and all that right is something that we're also working on developing, and we're working with RDH Building Science on quite a lot right now also. And I'm actually going to give it over. I'm just going to go right to James Bourget for a quick intro.
Hi, everybody. I'm James. I'm principal at RDH. I started off grandfather's contractor, and I got dragged to the job site at age 14, and I spent most of my life there till I was 40, which I fell off a roof, broke both my legs, and realized that no, I don't want to do that anymore.
Cool.
So I went back to school for architectural engineering and building engineering. And so I have worked both sides of the fence, so I can barbecue with anybody. Okay, it doesn't matter. You can talk fancy or you can talk nasty. It doesn't matter. I speak both languages fine. But I spent a lot of time working remotely. I live remotely, and I'm a curious George type of person. So there's a lot of talk about wildfire resistance, fire ratings from the inside, the outside, the upside, the downside. There's fire ratings all over. There's more standards you can shake a stick at. What actually applies? It's a really, really long and complicated conversation, but I'm not that person. I went to the simple side of life. I said the standards are kind of designed to see what it can do, but does it really represent wildfire? And what I like and what makes me tick is wildfire resilience, of how we can prevent and mitigate this from happening through constructible practices that are off the shelf but easy to achieve. Materials are there, just installed perhaps in a slightly different order, and using some neat products, like mineral and gypsum and all this kind of neat stuff like that. So today I'm going to just show you a few things that I do, but I build things at my studio and then I burn them. And I generally follow test standards, but then I take them to a more extreme level because there's one thing about a wildfire. The standards are all repeatable and predictable, but a wildfire is unpredictably predictable. And so I build things to a higher level and see how they would perform, because that's what will happen in a wildfire, because the wildfire is not going to match your standard, in case anybody's wondering. It kind of has a mind of its own. It's just going to do what the heck it wants, okay, based on its fuel and the surrounding conditions. So we'll talk a little bit about that today. I'm going to show some examples of some things that I've burned the living heck out of it and see how it looks after. And
Oh
I'll
yeah.
show you.
Yeah, we got a bunch of videos that are coming up
Yeah.
very shortly. So, and
Yeah. And so that's in a nutshell. That's all I do is stuff like that, and go around and present on it. So
well, thanks for joining
it's super
us.
cool. You'll see some things today that I'm going to ask before the next slide. Say, what do you think the end result was? And you'll wonder.
Yeah.
And then when I show you, you'll probably go, wow, that's it.
Yeah. And then next up, we have Chris Laumer Giddens. Chris, where are you calling from, and why do you have the funny hat?
Not
What's funny
funny.
about-
Not
What's funny?
funny.
I was gonna say, what's funny about this hat? It's totally normal. It's something everybody should be wearing, man.
That's right.
My stepdad was a builder, and he taught me that like when there are 2 or 3 ways to brace a wall, he does all 3. So he taught me about belts and suspenders from way, way back, and I have taken that to the extreme. So everything I see and want to do is always going to be, I want it to last absolutely forever. So I try to think old fashionedly, know where my layers are, be able to test it, see it, fix it, whatever, just like an old car. He also taught me how to work on old 64 Ford Galaxy. And you can understand that engine. And I want houses to be like that. I want to understand all the parts as I'm putting it together and as it operates. I believe spray foam is the next iPhone. Sorry, I just thought I'd see what the reaction I'd get there.
Speechless.
Anyway, so yeah, I'm an architect. I work for my wife, Jody, who's an architect. We build a lot of houses that are supposed to last a really long time. We consult all over the world. We design mechanical systems. We do a lot of off-grid work, passive house work, all that, because it all ties into that. We're doing an off-grid home project in Florida right now that's about 22,000 square feet. Say what you will, he's giving a lot of people jobs. So it's a great, all this exposure and talking about all the good stuff has made it possible to help the nation. So we're trying to do that one house at a time.
Awesome. Well, thanks again for joining, Chris. And next, I'm going to pass the mic over to Walt.
Hey, everybody. Walt Tamala from TNT General Contracting, the build, design, educate firm out of here in Westfield, Massachusetts. Super excited about this. I mean, being up a builder that does custom homes, high performance building, some passive house work, but more focused on resilience. We come from an inventory and stock of homes that are centuries old, and they function and they work really well, based off of the comfort levels they were built to back then. And we're building tighter, we're building more efficient, we're building comfortable homes that clienteles are looking for now based of changes in life. So how we approach it and what we do with it as far as our building practices, our systems, has changed a lot. We're going to learn a lot about that today with James and Chris and everybody. But yeah, I'm super excited about this. We don't do a lot with wildfires here in Mass, but we do a lot with resilient building and building buildings that are going to last for centuries. And the other passion that I have is I have 6 apprentices right now from trade schools, 3 different trade schools, and it's about getting the youth excited about what we do. Yeah, that's what I want to pass along. I want to get all these kids energized about it so they can geek out on PowerHour like we do. So thanks for having me.
Yeah, and thanks for joining once again, Walt. And yeah, if you missed the last PowerHour, it was on trade schools and support and all that. And then last but certainly not least, calling in from her vacation down in North Carolina. But where are you normally from, Paige, and what are you here to do today?
So I'm Paige Sherwood. I reside in New York. I'm the Northeast Regional Manager for PowerHour Installation. I've been here for about a year. I just like Dan, but not quite as good as Dan, have a background in mineral wool installation. I too previously worked for Rockwool, and then in 2020 I went to the Henry Company before I went over to Timber HP. So well versed in the building envelope, and insulation is always the name of the game. So I came back over to a mineral wool company, and I am joining everyone here to help moderate. So I'll pop in and out. When I turn my camera on, it's because there's a really good question that I think should be addressed in front of everyone. And please feel free. I'm going to make sure you can raise your hand, put questions in, and we'll find a way to let you, whoever's watching, all of you watching, you can engage. We want you to engage, because I think we all learn better when we all get to talk and then communicate and conversate about different ideas and the same beliefs. But yeah, so that's what I'm
This
here.
is-
I am on vacation. I'm fried, literally. Got a little too much sun today, so I'm hiding in the shade.
You need a bigger hat.
Hey,
Wearing a hat while looking for shark teeth would have been smart. So
Yeah. Well, thank you, Paige. And yeah, so anybody that does have a question, go up to the little comment box that has a question mark in it. And also, if you want, just chime in on the chat. Just chime in with who you are, where you're from. I do BS and beer also normally, and for Philadelphia. But put in what you're drinking too. Why not? It's a fun time.
this is,
So
and everybody, this is a safe space. So like, ask all the questions that you have. Don't hesitate. We'll answer them, and
yes.
everybody's welcome.
absolutely.
So first, you know what? I always start these with just kind of like a little bit of PowerHour training, 101. I want to go through kind of what is stone wool versus slag wool. And the big thing here is really, there's the mineral wool category, which we're talking about, but there are two subcategories behind the mineral wool, and one is stone wool and one is slag wool. So it's basically just what the main component is. And with PowerHour, it is a stone wool product, meaning that more than 60-70% is going to be made with the basalt, the Earth's crust, the most abundant resource in the world. And that's something that we pride ourselves on in making just a quality product versus some slag wools out there as well, which also, again, you're going to have the same fire resistance and a lot of the same attributes, but it's just going to be a little different on the composition. And just to kind of refresh everybody, we're talking exterior insulation when it comes to PowerHour for now. There are obviously, we're looking at doing other options out there for everybody, but we really wanted to focus on the exterior because if you guys know me, exterior continuous insulation is really where it's at. When you start protecting the home from the elements and making those structures from the outside a nice cushiony jacket of flannel is really the best way approach, and making that continuous is always going to be the best way. And I don't think anybody on here would disagree with that. So we have cavity board, we have ridgy board and curtain board as well. We have it all on the website. I'm not going to go too deep into each one of these right now because I really want to talk about wildfires. And this is just kind of like some different considerations. And I want to actually start with James. What are considerations that we should be making when we're designing for fire in mind, whether wildfire, whether it's any fires?
Huge question. That's what that is.
There goes the next 40 minutes.
I'll try not to go down the rabbit hole and look for Alice. Okay. The fires themselves, there's two different types. You get a wildfire, and then you get the community ignition. Okay. So the idea is if your neighbor's house catches fire, you're probably just going to run. Okay. There's not a lot you're going to do. Borosilicate glass, with fireplace glass or sealed units. I mean, I suppose you could go there and reach a level that would be incredible. But the key is to have it so that the community doesn't catch fire in the first place. And a lot of that has to do with the embers that can fly. A kilometer. And for those in the States, I'm going to be doing metric. Sorry about that. I did grow up with the American version, but I'm fairly old and I forgot it all. So at the end of the day, I look at it this way. If I'm going to design a home, I want to make it so if anything can fly or approach, or the hedge catches fire beside my home, or a pile of firewood, all the things that aren't supposed to be there, which is another part of the equation, okay? When you have your control zones around your home for the first meter and a half or whatever it might be, depending on, there are guidelines out there. I'm not going to get into all that. But you have a primary, an intermediate, and a distant type zone. But the problem lies in the community. That how do you get everybody to cooperate with that? Well, by the way, neighbor, you can't have that tree there. It's not right. That could be a problem. We do have software that we use so we can calculate the kilowatt exposure levels on various sides of your home based on vegetation. It's a whole different level of game. But at the end of the day, design the home so that embers can't land, collect, or light up under your deck, in your soffit interfaces, window ledges, gaps greater than an eighth, all these things have so your cladding doesn't catch fire. If we did that and managed that, we'd be a lot better off, because these communities that burn down starts with somebody burning down. But we've all seen the pictures where a community may burn down, but one or two houses don't. Why is that? So what does that tell you? That there's hope. That's what it tells me. There's hope.
Mm-hmm.
But we're lacking knowledge and coordination. All right. So manage the build. And you talked about resiliency, Walt. I agree 100%. But what's really cool, wildfire resistance and resiliency walk hand in hand. You can have both. They're just hand in hand elements. Okay. You put the fur on the outside, like nature put on the animals, put that on your home, make it wildfire resistant. I don't know, mineral wool comes to mind. And all of a sudden, the non-combustible cladding, and you've got a heck of a good start. You got soffits. Well, we all talked about soffits earlier. Maybe we don't want to have soffits. Why do I want an entry place for embers, right? Projects I'm working on, I have no soffits. Okay.
Mm-hmm.
It's a rain screen, highly resilient. There's so many things, and I'm probably just going to stop now, because I'm going to go off and off and off. And I don't want to okay? It's so entwined together. Resiliency, okay? Wildfire resistance, okay? Chris wants to have buildings last forever. Well, I tell you right now, if I take a wood structure and I put air and water controls on the outside, I put a thermal insulation on the outside, like Mother Nature did for the animals. If you're not sure, just look in the forest sometime. And then you put some cladding on the outside of that. I would ask, what's the failure mechanism? There is no failure mechanism, because the interior loading of moisture is handled. There's no condensation potential. Mm-hmm. And the outside moisture loading is handled because the mineral is hydrophobic. You stagger a couple layers. I was going to share one little thing in some places where I have worked and taught, is as we have chamber, and I built the exterior insulated walls with 2-layer stagger joints, and we test them to a standard. And for us up here, it's 720 pascals for high-rise window test, okay, which is pretty significant pressure. Well, I'm testing these wall assemblies at 9,000 pascals. 9,000. Wow. That's a 441 kilometer an hour wind with a rain rag, okay. And wow. in 2 years of courses, I never saw a drop of water on the sheeting membrane, because it put UV dye in the water and gave the students a black light flashlight to do the forensics after. Mm-hmm. And it's airtight, staggered insulation, hydrophobic. What mechanism is going to draw the water to the sheeting membrane? And so that's about the water part, but I have videos today. I'm going to show you what happens with the fire part.
Wow.
I'll stop.
Now, James, you brought up a really good point, and actually, Chris, you're working on a project right now, because you brought up, as you just shoved some food in your face. Question. With the vent, we talk about the venting and the soffit vents and all that, and you're in a climate zone 3. And what did you do on your project? So then you actually, it's not in a WUI zone, but you.
But we're building in a neighborhood where houses are pretty close to each other. Mm-hmm. And whether they're close to each other or not, it doesn't matter. When the wind blows, you could be 2 blocks away. It doesn't matter. So what we're trying to do is minimize any failure, any points of failure from fire, from wind, from bugs, from any external source. So it's been our practice to do a ventilated rain screen in the wall, of course, but then also on the roof we have a ventilation channel. And the idea is, of course, it cools the roof and it keeps it dry and all of that. But in our climate zone and many climate zones, we're taking that, we have 4 inches of stone wool insulation on the outside, and we're taking our plywood and putting it right on top. We're leaving a gap at the very top so that the moisture that's in the insulation has a chance, the vapor that's in there has a chance to escape. From the interior, we have the cavities filled. There's a vapor diffusion port on top of that. The insulation's on top of that. And I'll end with this, that the question I get a lot is, what about the roof overheating? What about shingle manufacturers and things? And James, you can correct me on this one if it need be, but it becomes almost a cold roof at that point, because your roofing is now on insulation. It's not over a 190-degree attic. So in a sense, it's a cold roof. So the issues of that hot attic heating up the sheathing and destroying your your roofing materials, why roofing manufacturers are concerned. That, I'm not saying it's gone, but it is mitigated. And we have a standing seam metal roof with, of course, it's going to bubble. It's going to kind of bow up a little bit. There's going to be a gap and there will be some movement of air underneath it. But we're going toward fewer gaps because no way for that fire to get into that roof now, because we don't have, it's all encapsulated. It's all closed in. The house is zero air leakage. There's nowhere, no ventilation channels anywhere for any fire to get in, no bugs to get in, and it all works. This doesn't work everywhere. We have to know that, but it does work, and you can get a similar assembly just about anywhere. You just have to know where all the rest of that assembly, how that whole system works. So that's what we're doing. Sandwich, bring it all together.
I spend a lot of time, I make roofs and I basically build a wall and then kick it over.
Yep.
Call it a day. There's my roof. It's a raised screen roof.
A floor is a wall is a roof.
Yeah, and it's really that simple. I mean, I'm just doing a project right now, metal roof, and it's a rain screen roof. And I have ember guards for the vent channel I have, because I have it on hot track. And there's a 1-inch space. And it's got perforated 1/8 diameter ember guards at the entry points and at the ridge. So no embers are getting in. And underneath that is, well, 8 inches of mineral wool. So happy camping, because they're not going to burn down.
Right.
It's very simple.
So in both those scenarios, are you guys framing and then sheathing, doing like high temp ice and water or anything, and then the rock wool, or I'm sorry, your mineral wool on top of that?
Well, for what I'm doing, I have a deck where I place my air vapor control on.
Yeah.
Then I'll have my insulation and my thermal clips and girts, whatever it might be. And at that point, then I put down a sheathing membrane on top of that, which serves as my rain screen or my wall. But for incidentals, it may get through. Yeah. If it sees an eyedropper of water in its life, it'll be a miracle. But I put it there anyway. And then I have the metal, and I have it directly on girts, no sheathing.
Yeah.
Okay. All right. So you can design your metal panels based on snow load or whatever you might be building, and the spacing of your girts, where you don't need to put a combustible deck up there.
That's right.
Okay. Yeah. Well, I got all this airflow and all that on this 1-inch little chamber here. It seems to work out just fine everywhere I go. If I put metal panels, to Chris's point, on a metal panel on a deck, I'll always put what's called an anchor mat, or what they call a ventilation mat, which is a Brillo knot or a filament top mat, 1/4 inch, compresses down. That allows, because in many climate zones, we get condensation under the metal, right? Yep. And if you design and you know there's going to be moisture, you don't design to mitigate that moisture, then you miss a couple letters in the word design. That's all happens. You got to zig. You got to zig.
Yeah.
You don't zig it, you design it.
That's it.
James, a wet building doesn't burn.
Well, it does other things though.
Oh boy.
All right. Until it dries out enough to burn.
Yeah. No, it's basically just take the same technology, like you said, wall roof, and flip it down like that. The whole idea of an attic roof is absurd. It's absurd. Okay, you know why we have an attic roof, right? Because industry, I'm speaking more from in the Canada side of things here, much of the state supplies the same, is that industry demonstrated the capacity to be unable to build an airtight ceiling plane. Because many times when you have a home in a climate zone that has a heating dominant, that type of thing like that, you're going to have this attic space and air leakage, but by default, what's the air barrier going to be? It's going to be that polyethylene or smart barrier, or whatever it might be, airtight drywall. I want you to look at your drywallers and make sure you're happy going that approach. So I'd be a little bit conscious of that. And the other thing is, how does it last over time? If you put an interior air barrier, it doesn't survive human usage over decades.
And how do you get 6-sided air barrier with an attic insulation?
And
like
that's
that?
the point. And so they use the polyethylene, but we can't make it airtight, so we put a vented space in there so we can deal with it. Okay, so we don't get a bunch of condensation on the underside of our sheathing. Which, well, up here in the northern, we get lots of that kind of stuff on the green side. You know, the moldy attics. You know, well, good luck trying to sell your home after, even though it's outside of your control layers. But everybody looks inside and sees all the mold, and the world's coming to an end.
I'm pretty sure you have the opposite your reason is the opposite of ours, that you get the mold in the winter, we get the mold in the summer.
Exactly.
Yeah.
Mhm.
It's all about
Exactly.
the
It is
It's where
reversed.
it grows.
yeah.
Yeah. And some places get it both summer and winter because it's
Well, I was going to say we just get it all year round because there's no
Yeah.
stopping the humidity here.
Yep.
Fair
That's
enough.
why your cockroaches get bigger and bigger every year.
That's right.
So,
Yeah.
but yeah, so this next one, I just wanted to focus mostly on the insulations that are available right now. This isn't really even exterior only, but you can kind of see different melting temperatures of different insulations.
Crazy.
You can see, obviously, stone wool is definitely going to be the highest at 2,100 degrees and up. So, you look at fiberglass being kind of the next lowest one, 900 to 1,200 degrees. Cellulose, closed cell spray foam, EPS, XPS, a lot of these are actually very low for melting temperatures. But I just wanted to kind of throw that up there before we get more into some of the different testings. Oh, sorry, Chris.
And let's go back one. I just want to throw out a suggestion and encourage the industry and anybody who's watching who has any influence. We could make everything so much simpler if we took this list down to the top 3 or the 1 and 3. Fiberglass can work if it's done right, but anything below stone wool, we can get rid of that. Denim, good idea, but it holds on to moisture too much. So does cellulose. I'm just saying that we are confusing the people who are building.
So there's only one, Chris.
Well, and I'm not, and you know what? I just realized I'm on a PowerHour webinar.
I thought you were going to tout vermiculite. I didn't know.
Well, anyway, go ahead, James.
I would agree, but I would expand. I would include the last one on that list also. It has an advantage for roofing.
Yes, I get that. My pushback on that one, other than the fact that it's foam, is that it still loses our value, and in your climate, it's even more extreme.
It doesn't, because I build a hybrid roof. I put 2 inches of mineral wool over top of it, so I kept existence, and now I maintain it. But I get what I need. I get the R value, and I save on the cost, and so. Yeah, that's what I say. I didn't say exclusive, did I? I just said we're going to keep it in mind.
You got to read the fine print, James. I got it.
I read the whole damn page.
His Oreo sandwich.
Is this how it's going to be for the next 30 minutes? Oh.
Anyway, with respect to the rest of the fuel, I agree with you 100%. I've never needed to design anything that I planned for the use of spray foam.
Yeah.
And I don't condemn it. I mean, everybody has their opinion. That's just my opinion. Okay.
Yeah.
If I'm designing all my controls on the outside, where am I going to put it?
Yeah.
Well, it's just not necessary. People think it's necessary, but it's not. Right. This is a whole nother discussion. Move on. I'll stop.
Yeah, please. Thank you. That's a good call.
And when you're choosing these materials, just these are the 3 really are tests. E84, E119, E136. I'm actually going to kind of skip through here because there's a lot of really, really great video content with even, I think there's a hybrid assembly from James that we're going to go into. And this is the first one. So James, would you mind just kind of walking us through what you were doing here?
This is just something that I did because, well, I have no life. So I'm on a weekend and I'm going to build something. I said, well, everybody talks about this mineral wool being so wonderful. So what if I built a wall with combustible cladding? And then I did a soffit interface, and half of it's aluminum and half of it's fiber cement. This is the second one. You can see on the list there, it says fire hardened soffit this time. The first test I did with heavy wood cladding on mineral wool, I burned it to the ground, but my aluminum soffit melted. And the whole thing burned to the ground because it melts at about 660 Celsius. I'm not sure what that is near
1,400 degrees Fahrenheit for aluminum cans.
These fires are cooking it at over 950. Okay, so I have ingots of aluminum dripping down in my video, and then it shot into the roof space and it took off like a rocket ship and burned to the ground.
Wow.
Okay? So this time I put sheet metal behind it, And when I burn this here, you'll notice that on the soffit with the aluminum side, it just starts to melt in the corner, but I'm using a slightly lighter weight cladding. The interesting part here with the roof part, and we'll get into it, is the Hardy has 1/4 diameter holes, and the perforated averages out less than 1/8 holes. And that has a direct impact on how much heat passes through that soffit. All right, so we'll see that going on. So I take this wall, I have Tyvek behind it. It's rain screen straps, wood, and the siding's on there. So I'm going to take this and I'm going to burn it right to the ground. I have my mineral wool side shield, so I'm just burning the specimen. No influence from anywhere else, just a snapshot on that wall. And I do that here, and then I'm going to ask everybody, on the top of that slide, it says, what will happen? What do you think is going to happen when we do the forensic and take it apart? There's my soffit, Hardy mineral wool. I have literally let it burn to a pile of ashes. All right. This is the mineral wool directly in front of the wood crib. So the wood crib that I made, the fuel cell, was directly against the siding. It was as if the plant or the hedge right beside my building picked up embers and caught my wood building on fire, but I had mineral wool behind it. I wanted to know how it would react to that one. The front of this mineral wool is actually melted. It's turned back into stone. It's hard as a rock. I literally melted it. What's interesting is this is the front side. What do you think the back side of that mineral wool looks like? Well, let's show them, Dan.
Brand new.
Brand new. And so it's kind of like a say what? So the front side is melted. It's 2 inches thick. Only 1 inch you can see the line at the top of the mineral wool where it actually was abused. The back side is still okay. So what do you think the condition of the Tyvek was? I'll show you. Here's the roof. Yeah. The Tyvek slightly melted, which I could do with a Bic ladder, same effect, right? But the wood and everything is completely untouched. You can see the difference between 1/8 holes on the left of the roof and 1/4 inch holes in the charring that was taking place from the heat passing through. That's why a lot of the recommendations are 1/8 diameter hole. It helps prevent embers as well as the amount of heat that's going to pass through there. Okay? And it's quite interesting to see. So when I built this one here, and it's like, I had no idea. What I was most surprised about, because if you ever work with Tyvek, you have a job and you might be doing a hot roof like a torsion or something, and there might be some sheathing membrane tie-ins that you wanted to save, but when you come by, the roofers have melted it all because that's what happens because nobody plans. It's so easy to melt Tyvek. And with that fire that burned well over 30 minutes, with temperatures in the 950 Celsius range, right against the cedar, only managed to slightly melt the Tyvek, and the wood has zero evidence of any charring whatsoever. And it's just like, I do these kind of things because where else are you going to get to see it?
Did you do any sensors on the stone wool to know what the temperature was of the stone wool? I'm just curious if the melting happened through just almost like the air gaps in the stone wool, the heat going through those air gaps and finding its way back there. Is that how, or maybe a seam? How did it melt it?
It melted, and I actually have thermocouples in the roofing that I'm going to show you with the same thickness of mineral wool, and I can tell you what the temperature was behind it for a roof fire built the same. But this was through the mineral wool direct, no seam. All right, and it's a heat sink, right? Like the mineral wool will hold a lot of heat, and that's why it's so effective on a roof with, for example, polyiso and over top, because if it holds the heat, what kills the roof membrane? Thermal cycling, right? So if I have UV and thermal cycling, so if I have a roof that's going to do this, but I keep it warm when the sun goes down and comes back and up and the temperature changes, but the mineral holds heat, it's going to do this. Well, which is going to last longer, this or this?
Yeah.
It's kind of obvious, right? And so I'll show you some more when we do the roof, and I'll give you a sense, because I built a similar top crib and the same type of temperatures that I registered with my high heat thermal gun. And I can tell you what the temperature of the mineral wool was on a horizontal fire. Another thing we do, we build high performance homes, and I see that people like to stick the metal through the insulation, and then I have to go to counseling. Okay, I get all bent out of shape, just like the metal. It's bent out of shape. It's just wrong, fundamentally wrong. And so I use what's called a membrane flashing. All right, and so I can mount my metal on the outside of the mineral wool, and as long as the potential for moisture that might generate on the water as if the barrier has a chance to come to the forward side, I've met the intent. Never mind the story I told you about the high pressure testing. No water's going to get there. Okay, if you put two layers in the middle, but some jurisdictions make me do this, and again, that's why we have a medical plan. Okay, I can go for counseling again. So at the end of the day, I want to say, okay, if I take this plastic membrane and I stick this through the mineral wool and I put it there and I light it on fire, will that plastic membrane carry through? So I said, well, I'm going to burn the living bejesus out of it. That's what I've done. So I built the fire and I just cooked this thing. And I did my best to destroy this. And I burned it to the ground. Again, you can see. Well, that's lovely. And so that's a pretty intense, everybody knows, everybody's had a campfire, right?
Mhm.
We know what it feels like. That's what they call SFH. You know what that stands for? Super freaking hot. Okay. So that's really hot. All right. So that's neat. So what about the membrane? What had happened when I took it apart?
Yep. Get in there.
You're the slide operator. I can't help you.
There you go.
So here's the membrane I put behind there. And you can see that it's not melted. It's not nothing. And that the mineral wool and the membrane, even on the top of the mineral wool, is sound. Again, the common theme about 1 inch fought off the heat. And after that, it was chill, Bill. And so found that quite interesting, where it don't matter if you run something through the mineral wool. All right, so I wanted to cross that off the list. And it's kind of the things that I like to do. I build little decks and I burn them and do all kinds of stuff like this, right? But
So,
this is just
James, question for you. Oh, go ahead.
So quick question though. So I know in like for NFPA 285 commercial code, they also ask for a non-combustible WRB. But if you're using mineral wool, does that really make any difference when you're doing these tests like this?
According to this, no, it doesn't make a difference.
well, according to the standard, also it doesn't. It's not an accurate statement. I made that note here somewhere. There is a heat release rate, and that for the membranes under the NFPA 285, which allow it to be used. Oh, where the heck did I put that here? Somewhere I had it. That's funny.
How about you, Walt? So you're currently building with mineral wool. What's the thickness that you're normally building with, Walt?
So it depends on what we have readily available. PowerHour, you're stocking it right down the road from us, so it's been great. But it's either 1.5 inch or 2 inch. I like 2 inch just because it pushes my dew point and everything for Mother Nature and the climate zone 5 to the outer side of the envelope. But sometimes we're, depending on our claddings and if we're gonna batten it or not, sometimes we'll go with 1.5 inches based off of budgets and such. But it still does. And what I loved hearing about this is that 1 inch, even if I'm at 1.5 inches, fire rating wise, I'm still protected on the inside of that PowerHour.
So in terms of thickness, James, I wondered if the 1 inch had to do with the density or the overall thickness, that you think that maybe the top inch gets melted, or meaning if we had a 1 inch on this wall, would it go to would only 1/2 inch burn and melt in that case, or is 1 inch the sort of, that's the thickness that melts in that period, or is it because just the overall thickness somehow it has the properties to just slow it down, and only a top layer of a 1 inch would melt? Or do you think it's sort of a magic number of like, is it just going to melt 1 inch?
Yeah, no, it's not a magic number, because one of the things about wildfire and testing like that, there's a time factor.
Yeah.
Everything based on a time, okay? A response time for firefighters. The standards, 8 minutes for a window, 10 minutes for a wall on the SFM 127A, whatever number you're doing that time. But at the end of the day, what I found, and to Walt's point also, that 2 inches of mineral wool is a good starting point for just about everywhere.
Yep.
All right. And so I use that as a premise. Says I'm not going to run inch, and I believe others have our rated walls based on 1.5 inches. Okay.
Mhm.
But I always start with a 2-inch myself. The only time I start with 1.5 inches is if I'm putting some dimensional cribbing in my wall and I want to infill between my cribbing for attachment points and all this other stuff that we might do. But a 2-inch. So I used it as a premise. And what I found interesting, your point, Chris, is it was the same answer every time I did it.
Mhm.
And so that gave me a level of comfort. Says, well,
Good.
I know that if I got 2 inches and I have an extreme fire, because all my tests, they ran for 30 minutes minimum.
Yep.
Other ones that I'm going to show you right now that I'm showing you, this is 70 minutes. This is a flying brand test, burning brand test. Not
Okay.
flying. So a big chunk has landed on the roof, and I've generated an 8-mile-an-hour wind, and I burned this. This went for 70 minutes. Okay, and I go right to the end of the extent. So this is a Class A roof listed assembly, which consists of, hang on, Chris, I apologize, but here we go. Polyiso, okay. Yeah, polyiso, and then on top of the polyiso, I got 5/8 Densdeck prime. Then I have a SPS base sheet, and a fire rated cap sheet. The part that I wanted to test, that the actual test standard only does, is they just do it on a flat roof, right? And they blow wind at it and see how the flame spreads and all this kind of stuff. Basically, how it performs. I did it at a parapet corner with the wind to develop a vortex and simulate the wildfire of something that might happen. See, the test standards assume the wildfire is going to conform to your test standard. I decided to conform to what a wildfire might do. And so I did it this way. And so when I took this apart, there was zero damage to the polyiso under, zero damage to the wood framing and the parapet of any kind, zero damage. The interesting part about the fire rated cap sheet is the expandable graphite and fire resistant chemicals within that blend. The graphite expands, like Halloween, you get those things you light up and they grow type thing. Well, the cap sheet does that. Even when you're degranulating stuff, you get these little wormies grow out. It's kind of cool. But at the end of the day, it develops this carbonaceous type char. So it makes a superheat shield. But here's the interesting part. And this is to your point, Dan, and I'll go far, or sorry, Chris. Underneath that fire, okay, you see the polyester, underneath that fire, I have a thermocouple.
Okay.
Underneath the 2 plies and 5/8 Densdeck. This, I burned this here, and at the time, I'm shooting up to 970 Celsius. Okay? Like you can see, that's freaking hot, okay? Right? And so 5/8 below that, my thermocouple, what temperature do you think that was on the underside of the Densdeck? It's 950 up top. How much you think's on the underside of that roof temperature?
200.
Yes, you have to play, participate, say something.
200.
200. Well,
450.
450. All right, this is like prices, right? That's kind of cool.
$1.
Oh,
The closest is Dan. The temperature was just below the boiling point of water, or 96 Celsius. Because the gypsum, with the chemically bound water, will release that in the form of vapor or basically steam and maintain the temperature under there.
Now, wait a minute. I was saying 200 degrees Fahrenheit, which is 212 degrees is boiling point.
Oh,
well,
fine print.
There's a nice weasel clause. That's
no,
fantastic.
I don't think in Celsius.
That's a fair point. You know what? Then Chris or Dan, you're not the winner. Chris is the winner. Okay. Anyway,
we're all winners.
The magic's in the chemically bound water within the makeup of the gypsum. Super cool. So I did the same thing here, but this time I have asphaltic coverboard over polyiso with a fire rated cap, because everybody gets confused. Oh, the cap sheet's fire rated, so it's a fire rated assembly. No, it's not. It's a Class A material, not assembly. So I did that to prove a point. And I think you can tell by the flames coming out of the cap flashing that it didn't work out so good. Okay. This was an identical test. the same weight, 8.8 pounds of crib, same moisture content, same everything, same spacing, size, everything, weighed the same. With the dense deck, 0 damage, listed Class A assembly. Without it, and just a fire rated cap, it burned to the ground. That really put some light into my mind, because we have these great discussions all the time, and everybody's trying to sell you, well, my material is Class A. Well, that's nice. But
was there any damage to the paper facing on the dense deck?
It was slightly darkened, but on the underside, it was untouched.
Got it.
It was, I don't know if I sent these photos, Dan, but when I took it apart, and I took the nozzle and I sliced it in half, right, so I could look at it.
Oh, cool.
Oh man, I'm just like gobsmacked. Okay, like this is like invincible. I built a freaking fire in the corner and I couldn't burn it down. The fire went out.
I think they have those pictures at the end of all the videos.
Yeah, okay. So this was a Class A assembly. The next one. Yeah. So this one here, this is a hybrid one. This is where it gets interesting. This is where I'm going to come back and loop around to your query earlier, Chris, about the temperature behind the mineral wool from the wall fire. All right. Mm-hmm. On this here, I have the same thermocouples like I had in the other one. I have one on the parapet, 9 inches in from the corner, right in line with the crib. And I have one underneath the crib, 9 inches by 9 inches from that corner. So right under that glowing red area, I have a thermocouple below the first layer of mineral wool.
Wow.
The dense deck reached a temperature of 200
Celsius.
No, I'm just teasing you. I went back to the American way. Okay. Anyway, it reached a temperature of 96 Celsius, or about the boiling point of water in whatever scale you wish to use. With the mineral wool, we went up to 186 Celsius.
Oh.
And
the temperature on the back side of the stone wool?
On the back side of that mineral wool after this fire was about 186 Celsius. I got the Holborn data logger. I haven't mapped it all out yet, okay? But at the end of the day, that's how warm it was, and that would explain why the tie deck just had this little melted spot on the wall. That's not enough to char wood. It's not enough for combustion auto. It's nothing. It's enough to make the wood warm. It's not even enough to really trigger decent pyrolysis.
It'll protect the house. Yeah.
Yeah. And so it was really quite amazing. What I found most interesting was that little bit of dense deck.
Yeah.
Provided a lower temperature than the 2 inches of the mineral wool.
Because the dense deck is only a quarter inch, right? I mean, or whatever.
The dense deck I had was 5/8.
Oh, okay.
The UL standard called for 13 millimeters.
Oh.
Okay, which is just over half. I used a 5/8.
Gotcha.
All right. And so the nature of the mineral wool, it holds a lot of heat. And what was neat with the dense deck one when I did this was after the fire had gone out, I leave the couplers in, okay, and I'm still logging it. Under the dense deck started to rise and it went up to 115 Celsius. And the reason for that would be, well, the combined chemically bound water had been extended, but it lasted 1 hour. How often do we hear 1 hour rating for the gypsum, right? You ever kind of correlate how this all comes together, right?
Yeah.
Super cool.
It's very cool.
And I have your images up.
Yeah, so you can see the thermocouples there and built. That's just a representative crib. The crib I used was in conformance with the Burning Brand test, ASTM E108, I believe.
Good job.
Okay, and these just show the 3 assemblies. And that's my playground where I play and build all these things, and then I go burn them outside. This is the end result of the one that had a fire-rated cap sheet only, with a typical roof assembly that's commonplace. Not exactly ideal. So here's some pictures here. That's the one that burned to the ground. There's my little burn corner over there. Here's the one with the mineral wool. Right here. So as you can see,
you got see where you cut it open.
Yeah, and so I just took I had a look at my bologna sandwich. I cut it in half, okay? and so I'm looking at it going, yeah, the mineral wool's warm and everything's warm, but the whole goal here is to protect the structure. The parapet is fine. It had dense deck on the parapet. All right. Had gypsum on the parapet, mineral wool on the floor. And when I cut it open directly where the fire was located, The polyiso is untouched underneath it. The mineral wool is still fine, and the assembly charred up with the intumescence within that fire rated cap. It's really, you look at the amount of heat, and remember this burned for an hour, okay? And it's just like, holy cow.
That's a long time.
God,
Yeah.
that's so
Yeah.
amazing.
So here's the one with the gypsum. You can see the remnants of the crib.
Oh yeah.
I cut this open with a dens deck, and the same idea. You see the plywood coping on the parapet. I mean, there's just no damage anywhere.
Incredible.
Nothing. So, did I give you a section on this one?
I think these are all the ones that I got. Oh,
All right.
that's it.
The point is, when I cut open for the dens deck assembly, there was no damage to the polyiso, not even discoloration.
Wow.
I ran the same test without a parapet on a standard roof assembly with a fire rated cap, and it survived the burning brand test, but the polyiso didn't look so good underneath, but it survived. All right. So that alone wouldn't constitute a good idea in my mind.
Right.
So it's also not a listed assembly. So if you're going to build something, make it a listed assembly.
Right.
And you get some sense now. The best part about these type of videos is to give you context to think about. Okay, how does it actually perform?
Yeah.
I burned the living crap out of it. Now you know.
Mm-hmm.
Awesome.
And I think by the time you get all done with it, it really is just like what we talk about with the 4 control layers, that 5th one being fire. I think we all agree that continuity is very powerful.
There's actually code changes are coming where we're working in Canada anyway, where at the national level to include in WUI zones that you do need a wildfire resistant barrier as one of your controls. So you need to design that way. And I believe by default, because you get resiliency to Walt's comments earlier, every house should have that because it doesn't take much to do that. And you're still going to meet Chris's needs, Walt's needs, and industry needs, and all in one swoop. Just connect the dots.
Yeah. That's well, and this is a lot. We talk a lot with people in Colorado and California, and they're my aunt and uncle lost their house, but we get a lot of calls from people who have lost their homes, and they're wanting to build back. You got issues with insurance, not wanting to pay to actually build it back better. They only want to build it, replace it, like as it was originally, which is full of spray foam and things like that. But this is an issue, like having that, like, what is it about what just happened to you, to your state and to your client that you don't want to pay extra to save their house, But anyway, sorry, I'm getting.
That's a moving target, Chris, because the insurance companies and the Institute for Catastrophic Loss and all the rest of this stuff like this, eventually will be the driving measure where you can't continue to keep paying out like this.
That's right.
It's okay.
Yep. Hey, some fancy details you got there, Dan.
Yeah. Thanks, Chris. Chris does this anywhere in the country or in the world.
What did you say?
I said your details you could use not these particular ones, but you could create details for everywhere in the world.
You could use these just about anywhere in the world. This is that assembly I was talking about that we did use the physics first framing where we built the shell first, and then we attached these wood rafter tails. The back end of it is flush with the insulation, so it's embedded in there. So what you have though is you don't have anywhere for the fire to get into the assembly. There's a gap there at the very top for ventilation for my rain screen, and behind that is just a thick layer, a 2-inch layer of stone wool. So if anything, the rafter tails burn off, and fine, we can rebuild that easy. But everything inside, and then our air, our air vapor, all of our control layers are outside of the sheathing. And I want to point out, I think I did this last time, but the 2 inches that we keep talking about, by the way, for anyone listening, that is the thermal control layer. When you got 2 inches and you've controlled the temperature of the sheathing, you're done with your thermal control layer. The added on the inside, learning more and more now that in the Southeast, we make our houses so cold, we might want to put a little bit on the inside to make sure that the sheathing stays warm all the way through. But the idea is that the 2 inches is enough in most places. The extra, everything in the cavities is the extra. It's part of your thermal, it's not your thermal control layer. So people ask that, they're like, well, but your cavity insulation isn't continuous, but that's okay, because that's not doing the thermal control that we're concerned about with sheathing and dew point and all of that. So you have to know your hygrothermic, so you have to know the drying potential of the entire assembly. But I just want to, anyway, it's an important thing to note.
Yeah, you're bang on, Chris. And with the 2 inches, it simply fluctuates based on climate zone.
Yep.
Okay, as long as you keep the sheathing above dew point, okay, you're laughing. It makes a difference. You're good to go. So some of the areas I'm off to the Arctic Circle shortly. I'll be putting more than 2 inches on the outside.
Wow. If you need a companion, just call me.
Yeah, it'd be great fun. I got to do blower door testing on 50-year-old log cabins that I'm retrofitting.
Hey, I'll carry the blower door for you.
It'd be a wonderful time. Yeah. Although there are no restaurants, hotels, or motels, and it's a flying community only. But
I've got snacks. It's fine.
We can hang out and talk shop. It'd be great fun.
James, that's your neighbor, right?
What's
the Arctic Circle? That's your neighbor.
Yeah, no, it's a different world out there for sure.
Yeah.
But the physics is the same. It's just you adjust it accordingly by climate zone.
Exactly. Physics is the undefeated everywhere.
Yep. Awesome. And great conversation, guys. I did want to bring Paige back on. If she is still on, she's on vacation. So I didn't see any questions come up, but I didn't know, Paige, if you wanted to say hello or had any questions yourself. I did get one pre-question ahead of time. Sorry, Chris.
No, her pupils are dilated. What's she been doing?
Sweating, to be honest. Sweating. Vacation's good. I'm not built for this consistent weather. Yeah, no, we had one question come in just about fibers from mineral wool and how to talk to customers and make sure they feel safe. I answered that. There was a comment that was not so much a question. Well, it was a little bit. It was, James, were you a pyro as a kid? Love it. Came through, which had me chuckling. Yes, clearly controlled pyro. But yeah, I thought it was great. It was very interesting. I'm just sitting up here on the deck sweating, but it was quiet.
Yeah. I did receive one pre-question, and it's really there's more and more electric vehicles out there, EVs. And when we start looking at these garage spaces now, can we start looking at fire hardening the inside to the outside? Or if it's an attached garage, which I always say the best garage is a detached garage. But how do we protect that? And what's that assembly look like?
I would say it's no different than an exterior wall. We do that anyway. If the attached, when we attach a garage, it's called the detached garage. We build our house first. So all our layers go all the way around, and we literally have a secondary shell. And one time we've done it where the wall that was, but instead of a thicker wall where it was a double wall, so the garage had its own wall, and we actually were able to build it and frame around it, so the garage popped up over the main house structure. So that whole structure stood on its own, the garage. And the way we detailed it, the structural engineer helped out. But we build all the layers of the main house and make it solid as if there's no garage. Then we build up to it so it looks like it's an attached garage. And then we put our continuous ventilation, putting the garage under negative pressure. So we're pulling all of the AC from the house into the garage. No, just to make sure there's no backdrafting into the house when that door is open. So But with these days now, like our current client in Florida, he's like, look, I don't put gas in the garage because I have electric vehicles. I don't put paint in there because I don't do the painting myself. So we're getting more and more where these garages are clean. So they're like, well, why am I worried about the backdrafting and why are we putting that ventilation in there? Well, you'll put something in there that's nasty probably. But anyway,
and if it's not you, it's the next homeowner that lives in that house too.
That's right. Yeah, it's not you. Yeah. So anyway, to me, that's how that wall between the house and the garage is an exterior wall, and then we just build around it. That's how.
Yeah, and what we've seen today, I mean, I'd be very comfortable with, like a Rigiboard 82-inch, and then even maybe for like an interior finish MGO board, because I've been seeing a lot more of that lately, magnesium oxide board, and that it's slippery and it looks nice and you could finish it. So, what about you, James?
Yeah, I don't have a problem with that. I'd use MGO board on the inside. I don't know if I'd use it on the outside. There's sweating issues and different chemistries that you got to look at with respect to that. But the fire ratings that we all talk about, we talked a lot about wildfire today, but that's a fire impingement from the outside.
Mm-hmm.
You can design class fire resistant assemblies from the inside. That's where most of the fire code comes from. The same point. So if you want to put a fire rating in your garage, so put a couple layers of gypsum on there and look at what kind of fixtures you have and be done with it. I like what Chris said, and I agree with that. And it's the same principle I'm using up north when I go is they all have cold porches for entries. That goes on after I wrap the house. Okay.
Right.
That works for your controls.
Yep.
It works for thermal continuity.
Everything.
And it works for wildfire because if you lose your garage, okay, you do a fire rating both inside and outside, you're probably not going to lose either one. But if your car catches fire and by some means it burns down, you don't want to burn your house down. So I really like the idea of separating the two. So it depends. Everything can be built to, let's just say one thing. Let's make one thing clear on closing. You can't build something fireproof. All right. That's not possible.
Right.
Okay. Yep. There are things more powerful than we are that they will cause it to burn. Murphy's Law, whatever you want to call it, something will happen that it could burn down. But we can prudently make that a harder thing to achieve for Mother Nature or Tesla, for whoever, electric cars, to burn our house down. We can smarter and better. And I think the last show you did with that PowerHour for education, that's really the missing link, okay? Because we can sit and talk about this all day long. But then when I go to site, they think I'm speaking in Mandarin or something, and I'm going to order dim sum. I don't know what they're thinking there. But at the end of the day, it's like, what are you talking about? How are we supposed to do that? And that's what we're missing on is the training and understanding. And I'm sure Walt and Chris and everybody's experiencing much the same as they just think I'm speaking in a foreign tongue. It's interesting.
Yeah.
Yeah.
It's all good.
Cool.
Yeah.
Can't make it fire.
Well, another great PowerHour, everything that we've imagined. And I think that was just really well done. So thank you, guys.
Thank you, Dan.
I'm very impressed, Chris, with the fact that you kept that double hat on the entire time.
What double hat? What do you mean?
So,
what do you mean?
Your Instagram post tomorrow should also include the double hat, I think.
Yeah, I think I can do that. I can do that.
If you want, by the way, James Bourget does have an Instagram as well.
Good.
It's just James Bourget, or maybe it's Bourget James. So you could check him out there. He's very, very new, so we'll welcome him into the Instagram family and get him on board and everything. But the other guys, LG Squared Inc., TNT General Contracting for Walt, myself is Dan Built Better Powerwool, and then Powerwool Page.
Yeah.
So awesome. Well, thank you very much, guys.
Thank you, Dan.
Until next time.
This was awesome.
Power on.
Power on.
Everyone.
Power to the people. All right.
Love it.
Bye, guys.
See ya.
See ya.